Hello everyone, here welcome to another video. We will be discussing questions from electronics. Electronics is a very mark-fetching subject in GIST or any entrance exam. So I assume that you have studied electronics. So here only we will be solving numericals. Okay? I won't be going into theory that much. So first topic I will start with op-amp, that is operational amplifier. This is one of the most mark-fetching subject in any entrance exam. So I hope that you finish it. And it's not hard, it's very easy. Operational amplifier, sorry. Okay. So we'll start with op amp. So see, op amp, the circuit will be like this. This is my first video of electronics in this total channel, so I hope you will like it. This part will be grounded. This is called your this is a feedback resistance. Okay, because why this is feedback? Because as you can see, this is going from here, like the output is connected to it. Okay, so this is called your feedback. This is a grounded, and this is called a virtual ground concept. That means the potential here will be like it will be equal to here, like this potential here, suppose Vx will be equal to the potential here. Okay, suppose Vy something. So here if you see Vy is how much? Vy is 0. So your Vx will be 0 here. Okay, because this is grounded, this connection is grounded here, so that's why your Vx will be 0, and this is your V input. Okay, and this is a simple resistance R. Is it all right? This is called, okay, operation amplifier. This is called as the input is connected to negative of the diode, it is called inverting op amp. Inverting means something that will invert the input. If the input is like this, it will invert it to this. Okay, inverting op amp. All right, and it will be gain. Some gain will be there. Okay, it won't be exactly like that. It will some some the gain will be there in the value of the input. Okay. So, what will be the gain? The gain will be V naught by V input, V output. This is V output by V input is minus RF by R. This is your gain. Okay, this is your gain. Is it all right? Okay, okay. Here we will do some nodal analysis. This is called nodal analysis. That means at one point we'll be calculating the potential or current. Okay, from Kirchhoff's law, if you know from Kirchhoff's law, the current uh, going into a junction, the summation of all the current is zero. Okay, that is what nodal analysis is all about. Okay, so here if you see, here the potential is zero, right? Zero. So zero minus Vi divided by R, that will be your current going in. So I will write zero minus Vi by R. Okay, plus see zero minus V naught by R. Okay, 0 minus V naught by R. RF. Okay, because this resistance is on RF. Okay. Hmm. And the current going here is actually 0. The current going into the diode is actually 0. So plus 0 is equal to total current, summation of all currents is 0. Okay. Yeah. So you may ask me why I took this in this like 0 minus V, because current going into it, I will take it as minus. So minus of it. Like minus of the original one, that will become this 0 minus Vi by R plus again 0 minus V naught by R plus this is 0 because this is going into the diode, so 0. So if I write it again, minus Vi by R minus V naught by Rf is equal to 0. Okay, so I will do it as minus Vi by R is equal to V naught by Rf. What is the gain? Gain is your what? Gain is a what? V naught by Vi. Okay, V output by V input. So I will take that one. So this will go to this side. V naught by Vi is equal to, that will go to that side, minus Ra by R. Okay, this is your gain. All right, this is your gain for inverting op amp. Okay, is it all right? Okay. This is for inverting op amp. That means inverting means when input is connected to negative of the diode, connected to negative terminal of the diode, negative of the diode. Is it all right? Okay. So this is an inverting op amp. Next is a non-inverting op amp. So that means input will be connected to positive of the diode. So next is a non-inverting op amp. Non-inverting op amp. So here what happens is this is a diode. Okay, this is again minus plus. I will take the minus in the upper part always. Okay, and here the negative part will be grounded, isn't it? And one thing, remember, the feedback will always be connected to the negative one. Okay, only then your virtual ground will be applicable. Hmm. So this is a V naught. So now this is your input. This is your input here. Okay, see one thing here. This is a zero. This is your input. So virtual ground concept will be applied. That means the potential here will be reflected here. Like the potential here will be equal to how much? This is VI. That means this is also VI. So this will come as VI. Okay, this is a VI. Like this is called virtual ground concept. Okay, and here see this is not grounded, but this is connected to positive here. This is negative. So we will always take this as the virtual like the that virtual ground concept thing. Okay, this is R. This is again RF. Feedback will always be connected to negative. Only then we'll be able to apply this concept. All right. Again, we'll start with it. See, Vi minus 0. We'll start, always we will start here. Okay, Vi minus 0 by R plus Vi minus V naught by Rf. Okay, now current going into the diode is 0 because every current we are calculating, isn't it? Every current, all the current at the junction plus 0 is equal to 0. Okay, so if you see, this is Vi by R plus Vi by Rf, sorry, yeah, Vi by Rf is equal to 0. So Vi by R is equal to V naught minus Vi. I just like did this minus thing. Okay. Okay. Now we know what we know. The out your gain is how much? Gain is actually your sorry V output by V input. So we have to somehow calculate V output by V input here. So if you see, let's do one thing. Let's cross multiply it. Vi is equal to R V naught minus RVI. Is it all right? Now what will I do? I will take this here. RFVI plus RVI is equal to RV naught. Okay. So I will take VI common VI. So RF plus R is equal to RV naught. Okay. So V naught you can take this V. Okay. VI, let's take the other side. Otherwise do one thing. Yeah. VI by V naught is equal to okay, sorry again. Let's take to that side. RF plus R divided by R is equal to V naught by Vi. Isn't it correct? So I will take simplify this. RF by R plus 1 is equal to V naught by Vi. So your V naught by Vi is what? Your gain. So gain is equal to V naught by Vi, that is equal to RF by R plus 1. So this is your gain in which op amp? This is your non-inverting op amp. Is it clear? Is it clear? Okay. Now op amp adder. What is it? What is it? So here if you see, this is your common potential for this, so I can take it as Vx, suppose. Okay, this is your whatever this is, negative, positive, and this is the output. So if you see here, I can write three equations because three currents will be coming, right? So I can write Vx minus CV1 by R1 plus Vx minus V2. Okay, yeah, yeah, one thing. Okay, wait. If you see carefully, see, this is your grounded, right? So your virtual the ground concept will be applied here. So this will be zero. If this is zero, then this is also zero, right? This is connected to this point, na, directly. There is no middle part here. So this will be zero also. So Vx is zero. So again, I will start here. If you see, uh, see. So here at this point, 0 minus V1 by R1 plus 0 minus V2 by R2 plus 0 minus V3 by R3. Okay, okay. And here also I can do this one, this step, that is plus 0 minus V0 by Rf is equal to 0, isn't it? Yeah. So I'll just take the zeros and minus V1 by R1 minus V2 by R2 minus V3 by R3 minus V naught by Rf is equal to 0, isn't it? So uh, I can write it as V naught by Rf is equal to minus of V1 by R1 plus V2 by R2 plus V3 by R3 whole. Okay, I will take Rf in the next step. So V naught is equal to minus Rf V1 plus R1 plus V2 by R2 plus V3 by R. Is it all right? Okay. Yeah. And if we suppose R1 is equal to R2 is equal to R3. Okay. So I'll just put everything is equal to R, suppose. So V naught will be minus Rf V1 by R plus V2 by R plus V3 by R. So I will take R as common. So that will be V naught is equal to minus Rf by R. Then this is your V1 plus V2 plus V3. Okay, this is the formula. You don't need to remember it. You just use the concept in every question. You don't need to memorize a lot of things. Just use the concept. Okay, is it all right? Okay, next question. Okay, we'll do a question now. First question. Okay, this is R, this is R, this is R1, this is R2. All right. Okay. Question is, what is R1 by R2? That is the question. Okay. See here, if I take this as Vx, can you tell me how will I calculate Vx? This is your voltage divider formula will be used. Vx is equal to, see how to use this potential into the one attached to this one. Okay, R2 divided by R1 plus R2. So this will be your potential at Vx. Is it all right? Now, if you see, this is positive, this is negative. This is your feedback loop, and this will be your virtual ground to here, isn't it? This voltage here will be virtual grounded to here. The virtual ground concept will be used, and this will be your Vx, isn't it? This will be Vx. So if I use the that my formula nodal analysis here, I will get it as Vx minus V1 by R plus Vx minus V1 by R plus Vx minus V naught by R is equal to 0, isn't it? So why I'm doing it 0? Because current at one junction, current at one junction, the total current summation of current at one junction is zero. That is Kirchhoff's first law. Okay, KCL law. So Vx by R minus V1 by R plus Vx by R minus V naught by R is equal to zero. Okay, so here it becomes 2Vx by R minus V1 plus V naught by R is equal to zero. Okay, now 2Vx by R, 2Vx is equal to V1 plus V2, isn't it? Yeah, I can write that. And Vx is how much? V2 into R2 divided by R1 plus R2 is equal to V1 plus V2, isn't it? Yeah, is it alright? Okay, so if you see V2 R2 is equal to V1 plus V2 whole into R1 plus R2. So V2 R2 is equal to V1 R1 plus V1 R2 plus V2 R1 plus V2 R2. So these two are cancelled. Okay, what is left now? V1 plus V2 whole into R1 plus V1 R2 is equal to 0. I will take that side V1 plus V2. This is you please try to do yourself. Okay, minus V1 R2. So our question is, what is R1 by R2? So we can find it from here. Take R2 to this side. R1 by R2 is equal to minus V1 by V1 plus V2. Okay, is it correct? Is it all right? Okay, so this is the answer. Okay, okay. Try this question based on this concept. K means kilo ohm. Okay, K means thousand. So instead of writing ohm again all the time, just okay. So please try this question. You have to find what? Find the value of V naught. Please try this question. You have 2 minutes. Okay. See, how will you solve it? Okay. This is your Vx, suppose. Okay. Whatever Vx will get, it will be like reflected here. So first of all, let's calculate Vx. It's a direct formula, isn't it? This voltage 4 into this divided by 90k, na? 90k plus 10k. Okay. So that will be how much? This is your 360 divided by 100, right? Kk will be cancelled also. 3.6 volt. Okay. So Vx is equal to 3.6 volt. So this is your Vx. So this 3.6 volt will be reflected here. So this will be your 3.6 volt, isn't it? Got it? Because if you see, this is negative. The feedback is connected to the negative, and there is virtual ground here. So you can say that. So 3.6 volt. Now I will just use it. Now, so 3.6 minus 2 divided by 10 plus 3.6 minus V naught divided by 100 is equal to 0, isn't it? So just take the LCM. This is your 1.6 divided by 10 plus 3.6 minus V naught divided by 100 is equal to 0. Okay. So take the LCM. If you take the LCM 100, this will be your 16 plus 3.6 minus V naught. That will be 0. So that will be 19.6 minus V naught is equal to 0. So V naught will be how much? V naught will be 19.6 volts. Okay. See how easy it is. It's also very fun to solve this kind of questions. Okay, next concept I will tell you. See, next is your integrator. Integrator. Hmm. So when it is called an integrator, see, when your capacitor, when a capacitor is connected to the output, okay, that is called an integrator. Capacitor connected to the output of op amp, that is called your integrator. Okay. So here, how will you solve it? See, here your V naught, your gain V naught by Vi will be minus Rf by R. We know it because this is an inverting op amp, and because Vi is connected to negative part of the op amp. So Rf is this one. We used to have Rf here, but here it is capacitance. But doesn't mean that capacitance doesn't have resistance. Capacitance has resistance. What is that resistance called? What is the resistance of capacitance called? Capacitive reactance, isn't it? Capacitive reactance, and we denote it by what? Xc, X subscript C, which is 1 by omega C, isn't it? 1 by omega C. Is it alright? Huh? Is it alright? Okay. So we'll just put it here. Vi by V naught by Vi is equal to minus 1 by omega C R. So minus 1 by R omega C. Okay. This is a what? This is a V naught by Vi. Okay. Alright. Suppose There are two now. There is this is another circuit where V naught plus minus. There is a capacitance here. This is 10k, 0.01 microfarad. Okay, this is R1. This is R2, 1k VI. Hmm. Okay, so this is this. Okay, now see, this is now a capacitance. This is now a resistance. Okay, so see, when there is only capacitance, we can take it as 1 by omega c. But when there is another resistance, okay, what will I do? Okay, there is one thing. This I have to take it as j omega c. Okay, j. What is j? J is your complex number minus or root over minus unknown. Because we also denote I as current, so I didn't take I here. It will be confusing. So I took j, which is your complex root over of minus one. Okay, so this is your j omega c. This just write it. So here, see here there is 1 by j omega c and there is R2. These two are in parallel connection, right? So parallel connection means R equivalent will be how much? R like xc into R divided by xc plus R, isn't it? So this is 1 by j omega c into R divided by um, 1 by j omega c plus R. But the thing is, now the thing is, okay. Anyway, the thing is, this these two cannot be added like this. Okay, we have to take their root over, like they will be added like this: R square plus 1 by omega square. Okay, yeah. So this will be 1 by j omega c. This will be root over of R square plus 1 by j omega c whole square. Okay, so R by j omega c. This is R square omega square c square my plus 1 divided by root over divided by j omega c. J omega cancel out. So R divided by 1 plus R square omega square c. Okay, so this will be your R equivalent. Okay, we can also call it impedance, isn't it? Total resistance, that is impedance. Okay, so this way we can solve this question. Okay, so the values that are there. Okay, this is your zero, isn't it? This is zero voltage here. This is zero, so I can write the equation here also. 0 minus vi divided by this is r1. R1 is 1k, so 1 plus 0 minus the whole okay, 0 minus v naught, na, v naught, 0 minus v naught divided by the resistance is how much? This one, r divided by 1 plus r square omega square c square is equal to 0. So you just have to put the values here. R is how much? R is 10k, c is this, omega will be given something else. Omega can be given like 15 radian per second, something will be given. You just have to put it there. Okay, and you will get the values. What we need v naught by vi. We need the gain. So I hope we can calculate it from here. Okay, yeah. Next, suppose here capacitance was connected to the output. So this is what we call it as integrator, right? Okay, if capacitance is connected to the input, what it will be called? What it will be called? Okay. So if capacitance is connected to the input, it will be called a differentiator. Okay, a differentiator. Is that all right? Hmm. Here again, also same thing will be applied. Just remember that this is called a differentiator. Okay, write a question now. Okay, so the question is VA. You have to find VA. Potential at A. Fine. Okay. See, here there is no negative feedback. If you see, always there is some feedback in other circuits. There is some feedback always, right? There is no feedback here. So when there is no feedback, the virtual ground concept won't be applied. That means this Vx won't go here. It won't go here. Okay. So this is all left alone. You just have to calculate here. So just write one point. If there is no negative feedback, there is no negative feedback, then no virtual ground concept will be there. No virtual ground concept. Okay. No negative feedback, no virtual ground concept. Okay. So this won't be reflected here. So we just have to deal with it. And one thing is there, the current will be always zero. The thing is, current will be zero whenever it goes to here. Actually, the current will be zero always into the diode. Okay, just remember that current will be zero into the diode. So, how will you approach it? So, 1 minus VA, 1 minus VA divided by what is the resistance? Resistance is 1K. 1K. So, voltage by resistance, that is your current. Current is 0. So, 1 minus VA is equal to 0. Okay, and VA is equal to 1 volt. That will be answer. Okay. Okay, next question. Okay, in the following circuit, in the following circuit, R2 is doubled. Okay, so question is, it follows that the current through R2 remains the same is half is doubled is quadruple. Okay, these are the options. So in fact, see again. Suppose current will start here. Okay, uh, R2 is doubled. Okay, current through. Okay, R2 is doubled. See, suppose current starts from here. So current will, as I said in the previous question, current to inside to a diode is zero. So there will be no current in this path, right? So all the current will go in this path only, right? So whatever change you make to this R2, it doesn't matter, right? Because all the current will be going through here. Even if I give 5 ampere, it will go 5 ampere will go. It won't be divided here because current into a dipole is zero. Sorry, dipole I'm saying diode. So if you give 6 ampere, the 6 ampere will go. So whatever you do to R2, it doesn't matter. Current will remain the same. Okay. So answer will be current will remain the same. rushing to homework. Okay, you have to find I not and negative. Okay, so this will be it for this class for OPAM. I hope you understood. Okay, there are so many things left in this OPAM, and we'll be taking some classes of this electronics. Okay, so I hope you understood. Thank you very much for watching.